Let's talk about improper integral. What is it meant by an improper integral? There's two types of improper integral. Type 1, integral with infinite limit of integration, improper integral type 1. If f of x is continuous on a to infinity, then the integral from a to infinity of f of x dx equal to the limit as b approaches infinity of the integral from a to b of f of x dx. So for example, you are looking at this type of integral. So here you have the function f of x. And here is a. And as a approaches infinity, and we want to find this area. Well, this is f of x. Now we can only know how to calculate. We only know how to calculate the integral from a to b. So if we just let b be a value in this an arbitrary value in the interval from a to infinity, and we let b approaches infinity, this means that we have the limit as b approaches infinity of the integral from a to b of f of x dx, right? And this only works if f of x is continuous in that interval. Well, if f of x is continuous on the negative infinity to b, then the integral from negative infinity to b of f of x dx can be calculated by the limit at a approaches negative infinity from of the integral from a to b of f of x dx. Now let's say if f of x is continuous on the interval negative infinity to infinity, saying you have some sort of situation where your graph look at it like this. Okay, so it continues from negative infinity to infinity. So then we can break this interval, this integral into a random value c, and normally we would want to use 0. Okay, and we split this to two integral. Then we can calculate this using the previous two cases that we know. Okay, so let's see how this works. Determine whether the area between the graph of f of x equal 1 over x and the x-axis over the interval from 1 to infinity is finite or infinite. What does it mean by finite or infinite? If it is finite, it will give you a number, a value. If it's infinite, then the area goes toward infinity. So first of all, let's take a look at this graph. The graph of f of x equal to 1 over x is, look at it like this, right? Here's at 1, and f of 1 is equal 1. Okay, and this is 1. And we are looking at this area underneath this curve as it approaches infinity. So then we are looking at case number 1. I will start with the integral. Well, this area is equal to the integral from 1 to infinity of 1 over x dx. This is the limit at b approaches infinity of the integral from 1 to b of 1 over x dx. So this is the limit at b approaches infinity of ln of x. Evaluate from 1 to b. So the limit at b to infinity of ln of b minus ln of 1. Well, ln of 1 equal to 0. So then we have the limit at b approaches infinity of ln of b. and this is infinity. So then the area between the graph of f of x equal 1 over x and the x-axis over the interval of 1 to infinity is infinite. Now, next thing I want to talk about is the volume. Find the volume of the solid obtained by revolving the region bounded by the graph of f of x equal 1 over x and the x-axis over the interval from 1 to infinity about the x-axis. So we start with the same graph. And this is the interval that in question. And we rotating this about the x-axis. Okay, so then the radius of this of the solid will be f of x, and the area that we use in the disk will be pi r squared. So the volume is equal to integral from 1 to infinity of pi r squared 1 over x squared dx. This is equal to the limit at as b go to infinity, the integral from 1 to b of pi times 1 over x squared dx. This equal to the limit at b go to infinity of negative pi over x, evaluate from 1 to b. This equal the limit at b approaches infinity of negative pi over b minus the limit at b approaches infinity of negative pi over 1. As b approaches infinity, negative pi over b becomes 0, and the limit as b approaches infinity of negative pi equal negative pi with a negative out front make pi. So here, note that here's the interesting thing. The area between the curve is infinite, but the volume is finite. So this problem, this solid generated by 1 over x is called a Grabiel horn. This is the Grabiel horn. We have the area is infinite, but the volume is finite. Let's evaluate this integral from negative infinity to infinity of dx over 1 plus x squared. I first will break this integral into two pieces, and I'll break this into the integral from negative infinity to 0 of dx over 1 plus x squared plus the integral from 0 to infinity of dx times 1 plus x squared. This means I can rewrite that integral as the limit as a go to negative infinity, a to 0 of dx over 1 plus x squared plus the limit at b go to infinity, integral from 0 to b dx over 1 plus x squared. So 1 plus x squared in the denominator, we look at the tangent of x. So then this is the limit at a approaches negative infinity, the tangent inverse of x. Evaluate from 0 to from a to 0 plus the limit at b go to positive infinity of tangent inverse of x evaluate from 0 to b. So this is the limit as a approaches negative infinity, the tangent inverse of 0 minus the limit at a approaches negative infinity of tangent inverse of a plus the limit at b approaches infinity of tangent inverse of b minus the limit at b approaches infinity of tangent inverse of 0. Okay, tangent inverse of 0 is 0. So then here, these two terms go to 0. Tangent inverse of a as a go to negative infinity is equal to negative pi over 2. The tangent inverse of b as b go to positive infinity, that gets you pi over 2. So this is pi over 2 plus pi over 2 equal pi.